Yo, what's up, guys? It's Talha here, and today is going to be our last video for this semester. And I'll have my final exams from starting from this Monday, and after that, so I'll have these exams for the whole next week, and they will be over on Friday. And then on no, not Saturday, so on Monday, I'll inshallah start making these videos again. And yeah, so for now, so for the whole next week, I won't be making any videos because I'll have exams. So I'll take off for the whole next week. But for today, what we are going to discuss, and today is going to be our last video for this semester, for this session. So what I'm going to discuss now is going to be about the antiderivative. And I'm going to introduce integration, or you can say integrals, and I'm going to tell you guys some rules regarding taking the antiderivatives, and I'm going to tell you guys the rule for, if we have time, I'm going to tell you guys the rule for the integration by parts, and integration by substitution. So I'm just going to give you guys an idea of what they are and how to use them. I'm not going to go into that much detail of each individual topic, but I'm just going to give you guys an idea how to use them and what they are. So first, let's start from the antiderivative. So up till now, we were discussing what was derivative, which was the rate of change. So as the word suggests, as it's kind of self-explanatory, that antiderivative will be the opposite of your normal derivative. So it means that, for example, if we want to find the for example, the derivative of x squared, so d by dx of y prime equals y prime means the dy by dx, so y prime equals d by dx of x squared. So what is this equal to? This is just equal to 2x. But the antiderivative, what antiderivative means is what is the 2x derivative of. So that means we have to do the reverse process and find the function itself whose derivative is 2x. So that leads us towards our towards our first rule of the antiderivative, that is your reverse power rule. So in differentiation, what we did, we applied power rule to our differentiation when we were dealing with the variable and that has an exponent on top of it. So the power rule was you subtract, you take the power and you multiply that power with your variable, making it a constant, and then you subtract 1 from the original power. So by that power rule, we get the derivative, that is 2x. But what the reverse power rule says, if you have the derivative instead and they want you to find the function and do the reverse process, so what you're going to do then, what is the reverse power rule? The reverse power rule says that you have to, so for example, we have 2x and they want you to find the antiderivative. So what you're going to do is, according to reverse power rule, you're going to add. So this is x power 1, So you are going to add 1, means that you are going to add 1, and then you are going to divide by the result, or by the result you get from this adding of up with the power of the x. So 1 plus 1, so that is 2x squared divided by 1 plus 1 is 2. The 2's cancel out and you get x squared, which was the original function right here. So what's the logic behind it? So it's as I stated earlier that the antiderivation or the antiderivative is the reverse process of integration. So in integration, what you did, you subtracted, you took the power and you multiplied it with the variable, making it a constant, and you subtracted 1 from the original power. But in the antiderivative, you will do, so you used to used to multiply the power with the variable, but in the reverse power, in the antiderivative, you divide the result or the power, and in the derivative power rule, you subtracted 1, but here instead what you do, you add 1. So this is the way, and that leads you towards the original function itself. You can also check it with you can also check it out with many other functions. For example, if we say that what is 4x power 6 derivative of, so that means we want to find the main function. And also whenever you find the antiderivative, you add a constant with that. The reason why you add a constant is because, for example, if I say that what is the derivative of x squared plus 2, the derivative of x squared plus 2 is 2x, same as this one. What if I say what is the derivative of x squared plus 5? Well, the derivative is also 2x. It is because the derivative of any constant is 0. So that does not matter, and the derivative is still 2x. So whenever you find the antiderivative, we don't know what constant what constant it was with. So that is why to remove the complexities, we add a constant, because that does not make a difference. And in some cases you have to you'll have a specific constant with the main function. So to reduce the complexities, well, what we do is we add a constant, and this constant can be any this constant can be positive, negative. So if it's negative, this plus will change into minus, and the whole process will remain the same. So here they want us to find the 4x power 6, and they want us to find the antiderivative. So what we are going to do is apply the reverse power rule, and what that says is you're going to so 4x, you're going to add the 6, and you're going to add 1, and then you're going to divide by 6 plus 1, and this will give you 6x power 7 divided by 7. So that means 4x power 7 by 7 is your antiderivative for the function 4x power 6. So now if you take the derivative, I forgot that you have to add the constant. This is really important. You always have to add a constant when you take the antiderivative, and I know I'm going to forget it many times during the videos and in the exam as well, but I don't have to. I have to take care of this in the exam. So now, so what we got here is 4x power 7 divided by 7 plus c. So now if we take the derivative of this term, we should actually get 4x power 6 in return, because this was just the reverse process. So let's take the dy dx of 4x power 7 divided by 7. So what this is going to be equal to is 4 by 7 is a constant, so it can just jump outside. So 4 power 7, and then you have the dy dx of x power 7. So according to the power rule, you have 4 by 7 into, so 7 becomes the constant of the variable. You have 7, and then you subtract 1, so 7 minus 1 is 6. And then what you do, this 7 cancel out, you get 4x power 6, which was our original function right here. So this means that we integrated it right, and here's a constant. So the you can have any term up to n with the constant, and it won't affect the it won't affect if you differentiate, because this will be equal to 0. And but to reduce the misconceptions, or you can say to reduce the complexities, you add a constant with the integrated answer you get. Now what we want to do is to introduce the integration or integrals. So first let me define two types of integrals. One is definite integrals. One is definite integrals and one is indefinite integrals. So indefinite integrals means that and also integral and integral sign. So integral is denoted by I, and an integral sign is like like an elongated S. So this right here is an integral sign, and this integral sign is used to take out or to process the antiderivative. So wherever you see this means that the process of taking out the antiderivative is going on. And also the integration, like the differentiation, is the process of finding the derivative. Same way, integration is the process of finding the antiderivative of a function, to get to the to get to the original function. So this is the sign for the integrals. And so definite integrals means that whenever you have an interval and you have the limits involved. So for example, this is a and this is b, and you have some, for example, x squared, and you have dx. So this right here will be a definite integral because it's definite, it's specific about an interval a and b. But indefinite integral, where you don't have any limits, so it's not specific, and x squared dx. So wherever you see a function like this, this means that they want you to find the integral of the or they want you to find the what do you say, antiderivative of this. So as I discussed, that the rule for the antiderivative is this, the reverse power rule. And some of the antiderivatives I want to mention here is so let me give you guys another example. You have the derivative. If I say that dy prime or dy by dx equals the derivative of sine x. So what's the derivative of sine x? Well, it's cos x. But what if I tell you that what is the integration, what is the derivative of cos x? Well, it's minus sine x, and we have proofs of these in the book, and on the you can find these proofs anywhere, so I won't go ahead and prove it, but you can find the proofs anywhere, and this is proven that the derivative of sine of x is cos x and cos of x is minus sine x. But what if I tell you that what is the, so what if I tell you that the indefinite integral, so what if I tell you that what is the integration, what is the integral of sine x dx? So what if I tell you what is the did I do it right? Yes, so what is the integral of sine x? So here you will say cos x, but it's not cos x because you know what is the sine x derivative of? So we know that minus sine x is the derivative of cos x, so we can multiply minus on both sides, and that way we'll get minus cos x. So this is going to be equal to minus cos x. So the derivative of sine x is going to be minus cos x, the antiderivative, and the integral of cos x dx is going to be sine x, because the derivative of sine x is cos x, so the reverse process it will be the integral of cos x is going to be sine x. Simple. Now what we are going to do is I'm going to just give you guys an idea of what is integration by substitution and what is integration by parts. So integration by substitution means that you substitute for example, if I say that you have an integration and you have to find the integral of sine of for example, if I say 2x plus 7 whole power something like 3 dx. For example, if I tell you to find the integral of this, so now here it's a little complex, because you know if this was sine of, for example, x power cube, that would have been more easier, but here you have a whole function instead of x. So what you're going to do is use the method called substitution. So what the method of substitution says is whenever you have the case like this, so what you do is you suppose the complex term you have, so this is your complex term, and what you suppose is, for example, let's say that 2x plus 7 equals your u. So we substitute 2x plus 7 with u, and now what we are going to do is sine of u whole cube, sine of u whole cube dx. And now it's pretty easy for us to find the integral of this right here. So how do you find the integral? Well, you use the rules I've stated before, and there are a lot of videos where I have explained the differentiation rules, the integral, and in this video I'm giving you guys an idea about the integral. And in the later on videos, after I'm done with the exams, I'm going to make the videos in detail, and I'm going to do some example questions of the integration by substitution and integration by parts. But for now, I'm just going to leave it here, and I just gave you guys an idea that what you do is you substitute for u, and you substitute the complex term for u. Now let's come to our integration by parts. So what integration by parts means, for example, if you have an integral and they want you to find the integral of sine, let's say that sine of cos x dx. So now here you have two functions, but what the integration by parts, the formula for integration by parts, it's a little complicated, but the easier formula for you will be, so what you do is f of x into g of prime, means the derivative of g of x equals f of x g of x minus f of prime x, means the derivative of f of x and into g of x. So right here no, here the sign of the integration. So here this formula, okay, so whenever you have this case and this formula, we derived it from the power rule. So the catch here is that you got this formula deriving the power rule. So this process, the integration by parts process, is actually the reverse. It's actually the reverse of your product rule. In case of differentiation. Alright guys, that's it for today's video. I'm running out of time, and we are going to meet on next Monday, inshallah, after my exams. Up till then, I'll take your leave. Take care. Allah Hafiz.